Your API container just crashed with ECONNREFUSED on port 5432. The database is running, so why the connection refused? Here's exactly why. Welcome to TheCodeForge. Before we dig into that production issue, let's cover Introduction to Docker. Docker is a containerization platform. It bundles your application with everything it needs into a portable unit called a container. Unlike virtual machines, containers share the host kernel, so they start fast and use minimal resources. Containers are not miniature VMs. They share the host kernel, which means they start in milliseconds and use megabytes of memory. This makes microservices economically viable. These 5 commands cover 90% of your daily Docker workflow. Master them first. Docker images are built in layers. Each instruction creates a new layer. Docker caches these layers aggressively. Order your Docker file so that the most stable instructions come first. Containers are ephemeral by design. For databases and stateful services, you need volumes. Docker Compose lets you define your entire multi-container application in one YAML file. This is the same issue we highlighted at the start. Here's exactly why that happened. Depends on, without a condition, only waits for the container to start, not for the service inside to be ready. Postgres takes time to initialize, but the API tries to connect immediately, resulting in ECONNREFUSED and a restart loop. The fix is to add a Healthcheck to Postgres and change, depends on, to use condition, service healthy. This ensures the API waits until Postgres is actually ready. As a defense in-depth measure, also add a retry loop in your application code. This is the mistake from the incident. Depends on, without condition. Service healthy only waits for the container to start, not for the service to be ready. Always pair it with a health check. The latest tag is mutable. 6 weeks later, it might point to a different version that breaks your app. Always pin to a specific version or digest. Using Docker exec to install tools in a running container creates a snowflake, modified and unreproducible. Use sidecar containers or build debug tools into your image instead. The article mentions start period, but doesn't show it in the compose snippet. Add a start period to the Postgres health check to prevent false failures during slow initialization. The article stresses application-level retry, but doesn't provide code. Here's a Node.js example using PG with Exponential Backoff. Modern Docker Compose v2 no longer requires the version key in Docker Compose, IML. The article's Compose snippets omit it, which is correct for Docker Compose v2 bundled with Docker Desktop 3+. If using an older standalone Docker Compose, v1, add version 3.8 at the top. When things go wrong, start with logs, then verify network connectivity and DNS resolution. For build issues, inspect layer sizes to see what's bloating your image. Let's run through some common interview questions. What is the difference between a container and a VM? Containers share host kernel, start in MS, use MB. VMs run full OS, start in min, use GB. How do you persist data in Docker? Use named volumes for production, bind mounts for development. What is the purpose of multi-stage builds? Separate build time tooling from runtime image, reducing size and attack surface. And a few frequently asked questions. What is Docker used for? Packaging apps into portable containers for consistent environments. Are containers the same as VMs? No, containers share host kernel, VMs run full OS. Is data inside a container persistent? No, use volumes to persist data across restarts. To recap, containers are not VMs, layer caching is key, multi-stage builds are essential for production, always use health checks with depends on and pin your image tags. Ready to go deeper? Up next, containerization versus virtualization, then Docker versus virtual machine, then how Docker works internally. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.